Look at this question. There is a spherical balloon of radius r. It subtends an angle of 60 degrees from the observer. So we're going to draw this observer who is on a flat horizontal surface. Since the height of the observer is not given, we are going to assume the height of the observer to be negligible. I'm going to observe this balloon from the ground level. And this question is slightly different. That's because the observer has the whole balloon to his view, which means he can observe the 2 points which form a line, the point of contact between his eyesight and the circle. So this will be tangential. The eyesight, the line of eyesight will be the tangential line to the circle. There are two tangential lines, and this angle, we usually consider the angle of elevation to be from the ground level in other cases, but in this question, the angle of elevation, it is not really the angle of elevation. It is actually the angle of 60 degrees, which is formed between the two lines of eyesight. So that will be 60 degrees. We are going to mark the center of the circle. There is one more information given. The angle of elevation of its center is 45 degrees. Now comes the angle of elevation. So which means the angle of elevation now is formed with respect to the ground surface. And this will be 45 degrees. This angle will be 45 degrees. Now I'm going to draw a perpendicular from this. This will be, we'll name this P. This is P. This is Q. We can also join this one, OQ. Now, since this whole angle is, I'm not going to draw it as an angle of elevation. This whole angle is 60 degrees. This angle is 30 degrees. This angle is also 30 degrees. Now, this angle will be, the angle OTP will be 45 degrees. This angle is an angle of elevation. This angle here is 45 degrees. Now, we have this as the radius. This is not, I mean, OQ is the radius. There is this another radius here. There is this another radius here, which is something like OS. Okay. Now, in triangle OST, the angle OTS is equal to, it's not really the angle OTP is actually 45. We have OTS here. OTS is equal to 30 degrees, correct? So we are going to make use of sine 30 degrees. Sine 30 degrees is equal to the opposite side, which is OS, divided by OS. That is nothing but the radius. OS divided by OT. So sine 30 is what? 1 by 2. OS is what? The radius. OS divided by OT. So R by OT. Keep this as it is. So R is equal to OT divided by 2. So in triangle OPT, since the angle OTP is equal to 45 degrees, the sides OP and PT become equal to each other. So this becomes H. If this is H, then your hypotenuse OT becomes H root 2. That's because 45 degrees. So sine 45 and cos 45, that will make OT is equal to H root 2. And now, since we have H here, I mean, we have to relate the height of the center and the radius. So we need to equate this OT with this OT. So I can rewrite radius is equal to OT by 2, H root 2 divided by 2. So we can say that H is equal to, if you cancel this, it becomes root 2 times. H is equal to root 2 times of radius, hence the proof.